Hello everyone, welcome to Learning at 11th Hour. In this video, I'll be introducing you all to the concepts of digital electronics, the very basics, and the subsequent videos which would belong to this playlist will contain concepts about sequential circuits, asynchronous circuits, etc. So let's dive into the world of digital electronics. So, have you ever wondered why most of the digital systems are binary? So, if you think about a computer processes whatever information we provide it with and stores it in the binary form, as in the form of ones and zeros. And most of the digital systems that we have come across, they are all binary. They use ones and zeros. So the reason being that the devices that are used to build these systems, the basic blocks of these digital systems, are actually devices which operate at two states. For example, if we take a diode would either be on or off, depending upon whether it is forward biased or it is not provided with any bias or reverse bias. And if you look at a relay, so the relay is going to be either energized, the coil of the relay, and then it would be either on or it could be in the off state if the coil is not energized. Or it could be made up of transistors. Now, transistors are devices which could operate in three regions actually: the cutoff, saturation, and the linear region. But when we talk about linear region, the linear region is usually used for amplifiers. So therefore, we are left with two other regions. One is the cutoff. In the cutoff region, basically the transistor is off, or it is the saturation region where the transistor is said to be turned on. So again, we have two states, the off and the on state. So be it a diode, be it a transistor or a relay, all the three have two states of operation, the on and the off state. And since these devices are used for building the digital systems, most of the digital systems are binary in nature. Binary in the sense they represent two states, the one and the zero. Let's go into the world of number systems. So, we are actually dealing with decimal number systems in our day to day life. The decimal system has 0 to 9, that is, it has 10 symbols to represent the numbers. So, what are the symbols that are available for binary number system? In a binary number system, we have only two symbols, either a 0 or a 1. Now, what are the range of numbers that the decimal number system can represent? So, when you ask this question, you have to ask another question: how many digits are we going to have in the number? So, if I say there's just going to be one digit, then there are 10 symbols, so we can have 10 numbers. But if I say there are two digits, then I can have numbers from 0 to 99, which means I can have 100 numbers. On the other hand, if I say I have three digits, if I can have three digits in my number, then 0 to 999. So I can have 1,000 numbers represented using the symbols of the decimal number system with three digits. Same way, let's look at binary. So for binary, if I say the number can have only one bit, so either it could be a 0 or a 1. So you can have a one bit number could either be a 0 or it could be a 1. If I say I can have two bits in my number, then I can have a combination of 0 and 1. So I can have 0, 0, 0, 1, 1, 0, and 1, 1, which means I can have four numbers. So this is going to represent 0, this is going to represent 1, 2, and 3. So I can have four numbers from 0 to 3 represented using binary. The other commonly used number systems are octal and hexadecimal. So in the octal number system, we are going to have symbols from 0 to 7. That is 8 symbols. That's why the name octal. And for hexadecimal, we are going to have 16 symbols. So it is going to start from 0 and go up to 9. And then it is going to have A, B, C, D, E, and F. So 10 symbols over here and 6 symbols from A to F. So that gives us 16 symbols. So we have in hexadecimal, we have 16 symbols, in octal 8 symbols, in binary 2, and in decimal 10 symbols. Now let us look at how we can convert from one number system to another. So let's look at the conversion from decimal to binary and vice versa. So let's take an example to do this. It will be easier for us to understand. So say I have a number 28 and I want to convert it from base 10. Base of a number is how many symbols the number system has. So the base of this decimal number system is 10. For binary, it is 2. So I want to convert it to base 2. So to do that, I have to divide this number repeatedly by 2. And the remainder is going to be the binary representation of it. So let's see how this is done. If I have 28, let me divide it by 2. So 2 ones are 2, 2 fours are 8. There's no remainder, so I'll put a 0 over here. Again, I'll divide it. 2 sevens are 14, no remainder, another 0 over here. 2 threes are 6, there is a remainder because the number is 7, so I'll put the remainder 1 next to it. 2 ones are 2, there is a remainder, so I'll put a 1 over here. I can't divide 1 further, so I'll stop the division, and now I have my binary representation if I can write it from bottom up. So the binary representation of 28 is now going to be 1 1 1 0 0. So I have 1 1 1 0 0 as the binary representation of 28. Suppose I have a decimal uh, number. So, for example, 28.3. So, it's like a fractional part of this number is also there. So, the base 10, 28.3 base 10 has to be converted into binary. In that case, we are going to convert the integer part separately, which we've already done. So, that would be 11100. And the decimal part has to be dealt with separately. So here I have 0.3. So I'm going to multiply it with 2 repeatedly till I have repetition of my result, or till I get all zeros or all ones and so on. So till as long as I reach some repetition, I have to continue this multiplication. For example, if I have 0.3, so 0.3 is multiplied with 2. What I get here is 0.6. So I'm going to retain the 0 as the representation in my binary form. But I have to continue this. So I'll carry forward 0.6 and multiply it with 2 again. What I get here is 1.2. I'll retain the integer part and carry forward the decimal part. Again, on multiplying, I get 0.4. Let me carry forward the decimal part, 0.8. Carrying forward 0.8 into 2, 1.6. So after this, again I get zero point 0.6 into 2. So after that, this part is going to repeat. So I'll get 1.2 again, and so on. So we can see that the representation of 0.3 decimal base 10 in my binary will be, now we have to write it in top to bottom order only. So this would be 0 1 0 0 1, and again 1 0 0 1, and this will continue as 1 0 0 1 and so on. So I can write this as 1 1 1 0 0 dot 0 1 0 0 1, where 1 0 0 1 is recurrent. So this is the binary representation of 28.3. So this is how we convert from decimal to binary. Say now I have to convert the binary form of a number into its decimal equivalent. So if I have to do that, what do I have to do? Let me take an example. Say I have 1101 and I want to convert it from base 2 to base 10. So I have to take each bit and multiply it with 2 to the power x, where x is the position of that bit in that number. So if this is bit 0, bit 1, bit 2, and bit 3, then how do I convert it into decimal? So I have 1 into 2 to the power 0, because the position of this particular 1 in this number is 0. This is 0 into 2 to the power 1. This is 1 into 2 to the power 2, and this is 1 into 2 to the power 3. Now I add up all of this to obtain the decimal number. So 2 power 3 is 8, 2 power 2 is 4, 0 into 2 power 1. So anything into 0 is 0. 1 into 2 power 0. 2 power 0 is 1. So 1 into 1 is 1. So that becomes 13. So 1101 uh, in the binary is actually 13 in the decimal. Suppose I have a number with a fractional part. So say I have 1101.01. This is my binary number. So here again, we'll deal with the uh, non fractional part separately and the fractional part separately. So this is 13. And how do I deal with this? Right? So for this, I'll continue with multiplying each of these bits with the position of these bits in the number, where, see, this is 0, 1, 2, 3. So the position of the bits after the decimal point is going to be numbered as -1, -2, and so on. So here the 0 would be 0 into 2 power -1. This would be 1 into 2 power -2. And I have to add this and put it after the decimal point. So what is 2 power -1? That is 1 divided by 2, but it is multiplied with 0. So I'll be getting 0 itself. 2 power -2. So 1 divided by 4 is 0.25. So 0 plus 0.25 is 0.25 only. So the decimal representation of this number, 1101.01, in the binary would be 13.25 in decimal. So this is how we convert from binary to decimal. So that's all with this video. Here we've learned how to convert a decimal number into a binary number and a binary number into a decimal number. And we've taken examples with numbers that have fractional parts. In the upcoming videos, we'll look at more such conversions into different number systems like octal and hexadecimal too. Thanks for watching. Please to subscribe to this channel.